Good day. The topic we are treating today is Geometric Progression 2 by Opola Monsurat Olajumoke. This lesson is a continuation of the topic Geometric Progression. In the first lesson, example 1 had been solved. So in this particular lesson, we will solve the second to fifth examples. Before we commence this topic, certain topics such as the geometric progression, how to obtain its common ratio, identification of its first term, the formula for obtaining its nth term, its general form, the formula for obtaining the sum of the first n terms for r greater than 1 and r less than 1, and the simultaneous equation and methods for solving them must have been known, so that by the end of the lesson, you will be able to solve different questions on some of geometric progressions. So these are examples, example 2, 3. The third example is a UTME past question. This is the fourth and fifth example. Now we move to the solutions of these examples. Example 2. In example 2, we are given a sequence of numbers. So we are asked to find the sum of the first 6 terms of that particular sequence. Before we can proceed to obtaining the sum of the first 6 terms of that particular sequence, we must check the type of sequence it is. Maybe it's an arithmetic progression or a geometric progression. For an arithmetic progression, we used to have a common difference. That is, if you subtract the first term from the second term, it must be equal to subtracting the second term from the third term. So let's try it with the sequence. 9 minus 6 will give 3. 13 and a half minus 9 will give 4 and a half. So since it is not equal, it is not an arithmetic progression because 3 is not equal to 4 and a half. So now we check if it is a geometric progression. To check if it is a geometric progression, we check if it has a unique common ratio. That is, if we divide the second term by the first term, it must be equal to dividing the third term by the second term, which must all be equal to dividing the fourth term by the third term. And that is what we have here. 9 divided by 6 equals 13 and a half divided by 9 equals 20 whole number 1 over 4 divided by 13 and a half. And if we should evaluate each of these, we get 3 over 2 as their lowest form. So since we have a unique ratio, a unique value when we divide the second term by the first, and the third term by the second, and also the fourth term by the third. Since we have a unique value, therefore that particular sequence of number has a unique common ratio, and that makes it a geometric progression with the common ratio 3 over 2. And also from the question, the first term is 6, which is usually represented by A. So now we have the parameters to obtain the sum of the first 6 terms, which is A and R. So now we obtain the sum of the first 6 terms with R greater than 1 That is, from here, 1.5 is greater than 1. So we know that we use the first formula for obtaining the sum of the first n terms. So this is the formula for r greater than 1. We substitute the value of a and r and the value of n. Since we are to obtain the sum of the first 6 terms, we know that n equals 6. So S6 will be equals to the value of A6 multiplied by the value of R, 3 over 2 raised to the power of n, which is 6. We subtract 1 from that, divided by R minus 1. So here, 3 raised to the power 6 will give 729. 2 raised to the power 6 will give 64. So we have 6 into bracket 729 over 64 minus 1 divided by half. So this can be written as 6 divided by half multiplied by the whole of this, which is the same thing as writing 6 multiplied by 2 multiplied by the whole of this. So 6 multiplied by 2 we give 12. We take the LCM here, we have 665 divided by 64. So here we simplify this to its lowest term. 4 here 3, 4 here 16, so it can't be simplified further. So 3 multiplied by 665 we give 1995 divided by 16. So the sum of the first 6 terms of the sequence 6, 9, 13 and a half, 20 whole number 1 over 4 is 1995 over 16. And that solves the second question. Now we move to the solution of the third question. In the third question, we were given the value of the first term to be 7 and the value of the fourth term to be 189. But we don't know the value of the common ratio, and we are asked to find the sum of the first 3 terms of that particular progression that has its first term to be 7 and the fourth term to be 189. So these are the 2 formulae for obtaining the sum of the first n term of a geometric progression. The first one is for r greater than 1 and the second is for r less than 1. So from the question, the value of the first term is 7 and the value of the fourth term, which we all know that we can represent it with t substrate 4 equals 189. So from the knowledge of the nth term of a geometric progression, we all know that this is the formula for the nth term of a geometric progression. T substrate n equals ar raised to the power n minus 1. So now we want to find the general formula for the fourth term, since that is the information we have in the question. T4 from that n term, when n equals 4, we have T4 equals ar raised to the power 4 minus 1. And from the question, the value of T4 has been given, which is 189. So substitute it here. 189 will be equals to ar 4 minus 1 will give 3, which is ar cubed. And also from the question, we were given the value of the first term a, which is 7. So that is where we have 189 equals 7r cubed. So from here we can see that the only parameter we have here is the common ratio, and that is what we are to obtain. So we make r cubed the sort of formula by dividing both sides by 7. So 7 divided by 189 we give 27, and 7 divided by 7 here we give 1. 1 multiplied by r cubed we give r cubed. So from here, if you are conversant with cube of numbers, you know that 27 can be written as 3 cubed. So 27 is 3 cubed, which is equals to r cubed. You can see that 27 is now in its exponential form. So we now equate the powers. We can see that this and this has the same power, so definitely the value for r will be equals to 3. So here the common ratio of that particular progression equals 3. And here we observe that the value for r is greater than 1. So since the value for r is greater than 1, we use the first formula, s subscript n equals a r raised to power n minus 1 over r minus 1 to obtain the sum of the first n terms. And from the question, we are to obtain the sum of the first 3 terms, since we now have the value for a and r. So therefore n equals 3. So now we substitute the values of a, r, and n into the formula for obtaining the sum, which is this. So now n is 3. We have s3 equals the value for a 7 into bracket. The value for r is 3 raised to the power value of n 3 minus 1 over r, which is 3 minus 1. So 3 cubed is 3 multiplied by 3 multiplied by 3. 3 multiplied by 3 is 9. 9 multiplied by 3 we give 27. So that's why we have 7 into 27 minus 1. 3 minus 1 we give 2. So from here 27 minus 1 is 26. 26 divided by 2 we give 13, and 7 multiplied by 13 we give 91. Therefore, the sum of the first 3 terms of a geometric progression whose first term is 7 and fourth term is 189 is 91. And that solves the third question. Now, we move to the solution of the fourth question. So in the fourth question, the information given is that the third and sixth term of a geometric progression are 108 and minus 32 respectively. So we are to find the sum of the first 7 terms. Here we are given the value for the third term and the sixth term, and you know to find the sum of the first n terms, we need the value for the first term and common ratio. So from the information given, we obtain the value of the first term and common ratio. So from the knowledge of the nth term of a geometric progression, t subscript n equals a r raised to power n minus 1. So from the question, the third term, which is t3, and here t3 will be a r raised to power 3 minus 1. 3 minus 1 will give 2. So that's why we have a r squared. And t6, that is when n equals 6, will be equals to a r raised to power 6 minus 1, which is a r raised to power 5. And from the question, we are given that the value for t3 is 108 and the value for t6 is minus 32. So substitute that into this. The value for t3, 108, equals a r squared, and that is tagged as the second equation. And also the value for t6, minus 32, equals a r raised to power 5, and that is tagged as the third equation. Now, we can see that if we divide the third equation by the second, we can eliminate a and obtain the value of the common ratio. So now, dividing 3 by 2, we have minus 32 over 108 equals a r raised to power 5 divided by a r squared. So minus 32 over 108 can be reduced to its simplest form by dividing both the numerator and denominator by 4. So 4 in 32 will give 8. 108 divided by 4 will give 27. So here we can see a, we divide a, that is 1. And from the rules of indices, r raised to power 5 divided by r raised to power 2 is same thing as writing r raised to power 5 minus 2, which is r raised to power 3. So now we write this Since this is in its exponential form, we also write this fraction in their exponential form. So 8 can be written as 2 raised to the power 3, and 27, as we know, can be written as 3 raised to the power 3, which is r cubed. You can see that all these has the same power. So since we now equate the powers, since they has the same power as r, definitely r will be equals to minus 2 over 3. So from here, we have the value for the common ratio. So we substitute the value of the common ratio into any of the equations 2 or 3 to obtain the value of the first term. So we substitute the r into the second equation to obtain the value of a, that is the first term. And the statement of the second equation is 108 equals ar squared. We all know the value for r to be minus 2 over 3, which is equals to a into minus 2 over 3 squared. I know minus 2 over 3 multiplied by minus 2 over 3. The first thing we do is negative multiplied by negative to give positive. 2 multiplied by 2 we give 4. 4 multiplied by a we give 4a, and 3 multiplied by 3 we give 9. So here we have 108 equals 4a over 9. So since we have to obtain the value of a, we make a the set of formula by multiplying both sides by the inverse of its coefficients. Since the coefficient of a is 4 over 9, we multiply through by 9 over 4. So if we multiply 108 by 9 over 4 and multiply 4a over 9 by 9 over 4. So if we should multiply 4a over 9 by 9 over 4, we are left with only a, which is equals to multiplying 108 by 9 over 4. So 4 here 1, 4 here 27. 27 multiplied by 9 will give 243. Therefore, the value for the first term of that particular geometric progression is 243, and the value for the common ratio is minus 2 over 3. Now we have the parameters to obtain the sum of the first 7 terms as we are asked to obtain in the question. So now, since r is less than 1, we use this formula for obtaining the sum of the first 7 terms. Here we know n will be equals to 7, so s7 will be equals to the value of a, which is 243, into bracket 1 minus 2 over 3 raised to the power 7 divided by 1 minus the value for r minus 2 over 3. So here we must be careful of signs. We must know the multiplication of signs. 243 into brackets 1 minus, if you multiply minus 2 7 times, which is minus 2 multiplied by minus 2, which will give plus 4. Plus 4 multiplied by minus 2 will give minus 8. Minus 8 multiplied by minus 2 will give plus 16. Plus 16 multiplied by minus 2 we give minus 32. Minus 32 multiplied by minus 2 we give 64. And 64 multiplied by minus 2 we give minus 128. So the same thing is applicable to 3 raised to the power 7, which will also give 2187. So we now deal with the denominator. 1 minus multiplied by minus we give plus 2 over 3. So we have 243. Here also minus, we multiply minus, we have plus. So we have 243 multiplied by 1 plus 128 over 2187. So 1 plus 2 over 3 we give 5 over 3. So from here we find the LCM of this particular figures in the bracket. We have 2315 over 2187 multiplied by the first term 243 divided by 5 over 3. So here 243 can go. We simplify this numerator to its simplest form. We have 2315 divided by 9 divided by 5 over 3. So 2315 divided by 9 divided by 5 over 3 is same thing as writing 2315 over 9 multiplied by 3 over 5. And if we should evaluate that, we have 463 divided by 3. Therefore, the sum of the first 7 terms of a geometric progression whose third term is 108 and sixth term is minus 32 is 463 divided by 3. So now we move to the fifth question. In the fifth question, we were given the information that the value for the second term of a particular geometric progression is 9, and the value for the fourth term is 81. So we are asked to find the sum of the first 4 terms. This is almost the same as the fourth question. So from the knowledge of the nth term of a geometric progression, which is given by this formula, if we substitute the value of n to be equals to 2, we have the second term, which is the same thing as writing a raised to the power 2 minus 1. 2 minus 1 will give 1. R raised to the power 1, we have r. So T2 equals AR, and T4, as we have in the previous question, is AR cubed. So from the question, the value for the second term is given as 9. So therefore T2 will be equals to 9, and the value for the fourth term is given as 81. Therefore T4 equals 81. Also, T2 is AR, therefore AR will be equals to 9, and that is tagged as the fourth equation, and AR cubed, which is T4, equals 81, which is the value for T4, and that is tagged as the fifth equation. Now we either obtain the value of A or R. So here we can see that if we should divide the fifth equation by the fourth, we can obtain the value of the common ratio. So here we divide the fifth equation by the fourth. We have AR cubed divided by AR equals 81 divided by 9. We cancel A, we are left with R cubed over R, which is equals to 81 divided by 9. So following the rules of indices, R cubed divided by R raised to the power 1 can be equal to R raised to the power 3 minus 1, and 3 minus 1 will give 2. So we have R squared equals 81 divided by 9 will give 9. So we can also write 3 in its exponential form. We know that we can also write 9 in its exponential form. We know that 9 can be equals to 3 squared, which is 3 multiplied by 3. So here now we equate powers, which is not a new thing. So if we should equate the powers here, we observe that the value for R equals 3. So now we substitute the value of R into any of the equations 4 or 5 to obtain the value of A. So now we choose to substitute the value of R into equation 4. And the statement of equation 4 is AR equals 9. So since we already know the value for the common ratio R, we substitute it here. We have 3A equals 9. So we divide through by 3 to make A the set of formula. So if you divide through by 3, we have A to be equals to 3 also. So now the value of A is 3 and value of R is 3. And from the question, we are to find the sum of the first 4 terms. So since we have the value of A and R, we proceed to obtain the sum of the first 4 terms. And from here, we also observe that R is greater than 1. So we use this formula. And from the question, we are to obtain the first 4 terms, which shows that n equals 4. So we substitute the value of A, R, and n into the formula for obtaining the sum. We have S4 equals 3, that is the value of A, multiplied by the value of R raised to power n, which is 3 raised to power 4, minus 1, divided by R minus 1, which is 3 minus 1. This is 3 into 3 raised to power 4 is 3 multiplied by 3, which is 9. 9 multiplied by 3, 27. 27 multiplied by 3, 81. Subtract 1 from it, divided by 3 minus 1, which is 2. So 81 minus 1 will give 80. That's why we have 3 into 80 divided by 2. 80 divided by 2 will give 40, and 40 multiplied by 3 will give 120. So the sum of the first 4 terms of a geometric progression that has its second term to be 9 and fourth term to be 81 is 120, which completes the solution of the fifth example. So these are exercises to solve to show if you really understood what we have been explaining. There are 4 examples in all, 3 from the past UTME questions and 4 an ordinary question. Next video will be on sum to infinity with sample questions and solutions. Please subscribe to our YouTube channel, like and share our videos. Thank you.